Hey folks, welcome back to the area of polygons, our unit on area. And we're going to talk about video 3 for the one lesson about parallelograms and triangles. Because we had to cover a lot of information, even though we thought it was simple. There's a lot of information to cover in the previous two lessons about dimensions and about units of measure. And so we'll continue with area of an irregular figure. Now, we got to remember the notes for what's going on. We'll take a look at this irregular figure. We'll get right into it. Remember the notes. We had the area of rectangles and parallelograms, base times height, and the area of triangle, 1/2 base times height. Remember, we did a lot of work about units of measure, and so we'll do the same thing. But let's get started with a fairly straightforward question. What is the area of this figure here? The whole thing. So how does this work? Well, it's kind of like the segment addition postulate, but this time it's area addition. So we're going to add the areas, and then we'll find the total area of the figure. So we have first the area of our little square down here. How do we know it's a square? Because all the sides are congruent. 4 right angles, 4 congruent sides are going to square. So this area of the square, if it's 6 inches along this edge, it's going to be 6 inches along this edge. And so we'll have 36 square inches, right? Because 6 times 6 is 36. And inches times inches is inches squared. So the area of the square is 36 inches squared. What then would be the area of the triangle? Well, look what's happening here. The triangle has a base of 6 inches, right? So our base of 6 inches times the height. Remember how the area of a triangle works. The area of a triangle is 1/2 the base times the height. So the area of the triangle is going to be 1/2 times 8 times 6, and that'll be inches squared eventually for inches times inches, right? So I can do this in my head. Here's how. 1/2 of 8 is 4. 4 times 6, 24. So the area of the triangle is 24 inches squared. So the area of the triangle is 24 inches squared. So that's our area. So the area of the triangle is 24, the area of the square is 36. We add the 2, and we get our total area. So area can be added. All right, so 24 plus 36, and these are inches squared, and these are inches squared. We can add inches squared. That gives us 60 inches squared. Okay, so the area of the total figure is 60 inches squared. Pretty straightforward, right? Yeah, well, let's make it a little more complicated. All right, so here, the question now is, suppose the base lengths of the square and the triangle and the figure at the right are doubled to 12, but the height remains the same. Okay? So let's suppose that the lengths of the square and the triangle are doubled to 12, but the height of each remains the same. So we're going to stretch it out. So this is what the question is asking, right? So what's going to happen if we call this pretty much the same thing? The heights remain the same. So 8 inches on the triangle, 6 inches on the square, but now we got 12-inch bases. How will the area be affected? So we can do the same thing, but I'm going to go a little bit quicker. The area of the rectangle, 12 times 6, that's going to give us 60 square units. Okay? So, or excuse me, 72 square units. So we have 72 squared inches in the rectangle, and then 12 times 8, of course, is 96 square inches, but divided by 2. Okay, so half the base times the height. Or, again, 4 times 12. So we have 8 times 12, 96, but it's half the base times the height. So half of 8 is 4. 4 times 12, of course, is 48. Either way, the area of the triangle is 48. So we have our 48 and 82. That gives us 120 squared inches. Okay, so that's what would happen if we doubled the length to 12, kept the height the same. We'd have 120. How does that compare to the original measurement? It's double, right? So what would happen? How would the area of the figure be affected? The area would double. Isn't that interesting? The area would double. So I'm going to start asking some neat questions. What then would happen if both dimensions were doubled? Because the question was, what would happen if only one dimension was doubled? The area would double. If one dimension was doubled, the area would double. So let's use algebra for a second. Okay, so here's the original figure. We have the area of the triangle and the area of the rectangle. And we add the 2. right? So we have 1/2 base times height plus 1 base times height. That would give us 1.5 base times height. That's what would happen. Okay, so that would be the original area. The question that was asked in type is, what if only one of the dimensions were doubled? So the area of the triangle is 1/2 base times height, but we're going to double the base. And the area of the rectangle is base times height. We're going to double the base. So now we have this. Okay, so 1/2 of 2 times the base times height plus 2 times the base times the height. And remember what the answer was. If we doubled one dimension, we would double the area. So if the area of the original was 1.5 base times height, wouldn't this be 3 base times height? And the answer is, yeah, it should be. So 1/2 of 2 is 1, right? This is 1 base times height. So 1 base times height plus 2 base times heights give us 3 base times heights. Right? So again, the area is doubled. Now here's my question. My question is, what would happen if both dimensions were doubled? So let's see what that looks like. If both dimensions were doubled, we'd have 1/2 times base times height, but the base is doubled, 2 base, and the height is doubled, 2 height. And then we'd have base times height, but the base is doubled, and the height is doubled. What would happen? So here we go again. 1/2 of 2 is 1, so this is basically 2 base times height for the triangle. And then 2 base 2 height is 4 base times height for the rectangle. That gives us 6 base times height. What's interesting, the original was 1.5. The new area is 6. How does that compare? That's 4 times. That's not double, that's 4 times as big. So the area would expand 4 times as big, right? So, isn't that interesting? It's double squared. Because 1.5, 4 times is 6. So 4 times as big. And that's enough for today. Hopefully you understand how the area of an irregular figure works, and we'll catch you on the next lesson. Bye-bye.